Now, the next question we'll do question 4 from this reading. So this involves, as I've said, the law of total probability. Okay, so what is the question? The probability that George will study for the final is 4 over 5. Let me just try to make the whole question visible for after. Okay, so the probability that George will study for the final is 4 out of 5. The probability that he will pass, given that he studies, is 3 out of 5. The probability that he will pass, given that he does not study, is 1 over 10. Now, given these probabilities we have, what is the probability that George will pass? Okay, so I'm just going to write down for myself what these are. So that, again, we'll use S, the sentence S, to stand for the probability that George studies. So the probability of S equals 4 over 5. The probability that he will pass, given that he studies, is 3 over 5. So that means we'll say the probability that he will pass, given he studies. So the probability of P given S equals 3 out of 5. And the probability of P given not S, given that he doesn't study, is 1 over 10. And we were given that information, and now we're asked, what is the probability of P that he will pass? And so if you recall what the law of total probability says, which I'll write down in a second, what it tells us is a way of understanding the probability of a single sentence in terms of these conditional probabilities and the probability of another sentence. So let's see how that works. Let me just erase. All right, so what the law of total probability says is as follows. The probability of some sentence phi equals the probability of phi given any other sentence psi times the probability of psi plus the probability of phi given the negation of that sentence psi times the probability of the negation of that sentence psi. So if you look at the readings and the video lecture for this day, when I talk about this law, in the readings and in the video lecture, it's discussed why exactly this holds. Okay, so if you go through the proof or the justification for this law, it will hopefully make more sense, which is something I highly recommend. But one thing I note is that you can hopefully see why this holds by considering the logical equivalence, which we saw in the previous unit on deductive logic, which was that a sentence phi is equivalent to the following complicated sentence. So any sentence phi is logically equivalent to phi and psi or phi and not psi. That's because psi has to be either true or false. So either psi is true or not psi is true. One of those two things has to hold, either psi or not psi. So that means that saying phi is kind of the same as saying phi and psi or phi and not psi, because one of these two possibilities has to hold. But in any case, I'm not going to go into detail now about justification for this law, because you can see that in the readings in the lecture. What I will do is show how we can apply this law to the question at hand. And the question at hand, to recall, is what is the probability that George will pass? And what we know is we know the probability that he will study, and we know the probability of him passing if he studies, and we know the probability of him passing if he doesn't study. So if we were to apply the variable psi here to S, him studying, we will actually see that we have all the information we need to fill out the right-hand side and therefore calculate the probability of P, or which stands for phi in this case. Okay, so let me just instantiate the rest of this law where psi is the sentence S, and then of course phi is P. So what this law tells us is that the probability of P of him passing equals the probability that he will pass given he studies times the probability that he studies plus the probability of him passing given he doesn't study times the probability of him not studying. And if you recall from the question, we know we're given this probability, the probability of him passing if he studies, that is 3 over 5. And we're given the probability of him studying, which is 4 over 5. And we're given the probability of him passing if he doesn't study, which is obviously much smaller, 1 over 10. And then wait, we're not in the question given directly the probability of him not studying. But we are given the probability of him studying, and recall the rule for negation, which says that the probability of a negation of a sentence equals 1 minus the probability of that sentence. So because we're given the probability of S, we can just simply figure out the probability of not S, which is 1 minus 4 over 5, which is the same as 5 over 5 minus 4 over 5, which is 1 over 5. So in that way, by using this rule for understanding negations, we see how the question has given us all the information we need to fill out the law of total probability, its right-hand side, to determine the probability of passing. And now the rest is simple mathematics. So just to work through this, 3 times 4 is 12, 5 times 5 is 25, and then 1 times 1, and then 10 times 5 is 50, and then to even out these denominators, we just multiply this, both denominator and the numerator here by 2, so we get 24 over 50 plus 1 over 50, and this equals 25 over 50, which is 1/2. So the answer is that in this case where we're not sure whether George will study or not, but we know the probability of him studying, and we also know how likely it'll pass in either case of him studying or him not studying. In that overall situation, we know that the overall probability that he will pass is 1/2. And so now we can just easily verify that is the correct answer to this question.